I'll turn it over to Puneet as we dive into more about encryption consultants and the technical part of the presentation. Thanks.
Thank you, Mark. I appreciate it. And throughout this whole course, if you have any questions, please feel free to put them in the questions and answer area. My counterpart, Lauren Richards, which is our marketing, she will be answering those and responding to those during the call if applicable. But we'll wait for everything at the very end, and we'll try to answer those calls. And we will make sure to follow up with everybody also with our contact information. So if you have any additional questions, you'll make sure to have all that information from us. So again, thank you. And Puneet, it's all yours.
Thank you, Tim. Just wanted to give you guys a little bit background about encryption consulting. We are a startup and we have been in business for almost 2 years. And we focus on consulting in the PKI, HSMs, encryption, tokenization, and masking space. And we recently launched a code signing product, which is integrated with nCipher as a service, which is a cloud offering of HSM, which nCipher provides, as well as on-premises HSM solution of nShield Connect. That being said, in the next 30 to 40 minutes, I'm going to talk about what exactly is code signing and what are the different practical use cases the code signing is being used in the different organizations, and what are the different threats or the risk which I have seen in my consulting experience in last 16 plus years. And then we'll talk about that. We'll do a little bit deep dive into the code signing, that how exactly technically the whole thing works. And at last, we'll wind up with talking about some of the industry best practices which are out there for the code signing. And we'll also talk about a case study where people didn't took care of it and what were the impacts and what were the bad things happened to them. That being said, what exactly is code signing? If I talk about a simple layman terms, as humans have got a birth certificate which acts as their identity. Similarly, code signing is something like which acts as an identity for the code. And if you talk about in the technical terms, if I say in the like a really cryptographic terms, the code signing is a process of digitally signing the executables such as EXE, DLLs, and other things, so that the author's identity can be proved, and it also gives the assurance to the end user that the code has not been tampered. So it kind of maintains the integrity about the code, about the integrity as well as the identity of the code. Now, if we talk about high level exactly that how this whole code signing works, so if you think of any software publishers such as Google, Microsoft, or Apple, what exactly they do is that they write the code, and the output of that code might be in Windows platform like a EXE, DLL, or anything. What they do is that the developer generates a public and a private key pair, and that in the PKI terms we call it CSR, certificate request, and they submit that CSR to a certificate authority. And certificate authority takes that public portion in the CSR and signs with its private key and returns back the software publisher a code signing certificate. And the software publisher uses that code signing certificate along with a signing tool, such as on the Windows platform, you have the sign tool on the Windows 2012 server and 2016 server. And then basically that whole package is bundled up. We'll go in much more deeper in after a few more slides at how exactly all the cryptographic functions what are involved in this whole code signing process. That being said, that why do I need the code signing, like as an organization or an end user, why do they need the code signing? The thing is that if you're using any package, like if you're using Windows, Linux, or Macintosh, whatever you're working on, you have to install the new package or you have to update the packages. And you have to take a kind of an instant decision that when that pop-up comes, should I install this update or should I not install that update? And if you see on the right-hand side of the screen, these are the two kinds of pop-up which you normally get on the Windows. One with a yellow screen where if you will see that the publisher information is unknown. And on the right-hand side, the blue pop-up, it kind of tells you exactly that it was published by the Microsoft Corporation. Now, If we talk about the yellow pop-up where the publisher information is unknown, that gives you the indication that the code was not signed, or if it was signed using the self-signed certificate, because your machine is not able to trust the certificate chain or the certificate which is associated with that particular code signing package. Now, most of us works in the security space, so we know that what's the difference between this yellow pop-up and the blue pop-up. And the normal people who doesn't work in the security, or there are people who just use computer for day-to-day usage, they would just click yes even if the yellow pop-up comes, and that can lead to the malware installation on their machine, and which can lead to the much more bigger problems like identity theft and other things. Now, if we talk about what are the common challenges what are present with respect to the code signing as of right now. Now, if we relate this problem to your organization, that if you're developing any custom code or any application within your organization, what exactly is happening? The most of the developers which are out there, they would have generated the public or private key pair on their machine, and they would be just signing the code on their machine. So if you think that if you have got a 10 business units, so they are like a 10 different developers which are out there and they are signing the code. So you have got 10 keys which are out there on their laptops. And so the key sprawling becomes a big challenge, like the key management is becoming a big challenge on that. Second thing is that, like, since there is no process that who actually approved this code signing, that the package which the developer is signing, did somebody look into that package? Did somebody approve that? Was that package being scanned by the virus or a malware scanner? Blah, blah, blah. So since it's kind of an ad hoc based process, so there's no like a control over the auditing as well as on the signing process. The third biggest thing what I have seen is that like since there's no validation of the whole signing process, so there's no audit trail which is maintained. So down the line, if somebody updates their machine and they update it with the malware package, there is no way basically to track it down that what exactly went wrong, since there was no audit trail being maintained because the developers are doing it on the ad hoc basis. So these are some of the common challenges what I have seen different enterprises facing. Now, if we talk about from the risk perspective, that what are the common risks which are there. Now, first example, when I talked about that, the developers just generate the public and private key pair on their machine, and they are not aware that basically that somebody can take the memory dump and can walk away with those keys, or since it's just a software-based keys, and Microsoft uses a DAPI APIs, and there are applications like Jailbreak and other things which can easily get, using which anybody who has that laptop can get hold of the private keys. So the top 2 or 3 threats what I have seen is that the theft of the private signing keys, and that's one of the most common threat what I have seen. The second threat I have seen is that similarly related to that signing keys, if the certificate authority keys which is issuing the code signing certificate get compromised, if certificate authority are not using the HSMs for protecting their private key portion of the keys, those certificate authorities can be compromised and they can issue the code signing certificate to the unauthorized people, which can lead to much more bigger problem because those unauthorized people can sign the malware or do the signing of the code signing packages which are not genuine. Third biggest challenge what I have seen is that when developers who doesn't want to buy a public certificate, they will go and generate a self-signed certificate. And when they use a self-signed certificate, they use kind of an insecure or the low cryptography. Like if the industry standard as of right now is to use the 2048-bit RSA key, they would go for the 1024-bit key, or not going for the high-end cryptography or the hashing algorithms and other things. So those are the few of the challenges what I have seen, and whenever the key gets compromised, if it goes to the hacker, they can sign the malware package on behalf of your organization, and that can do like a brand damage or the big reputation damage for your organizations. Now, as a cybersecurity consultant for the last 16 plus years, I normally always recommend to my customers that they need to incorporate the code signing process within the software development lifecycle. It's best to have the code signing process integrated within the build process, and in spite of having the manual process automated, so that like whenever the build using the GitHub or GitLab, whatever your developers are using, they integrate this code signing process, and whatever the build get released, it's kind of signed. Now let's do a little bit much more deep down that how exactly the code signing process works in the cryptographic world. So if you look at this particular slide, what happens is that normally the code package is being passed through a hash function, and that gives you a digest about the code. And in simple terms, cryptographic terms, that digest is kind of the thumbprint of the code, and that thumbprint of the code is being signed by the private key. Now, that hash signed with the private key, the code, and the certificate is kind of whole package becomes a code signing bundle, and that's what is whole actually how the code signing works. There are different tools which are out there for the code signing which are available. For example, if you're doing signing on the Windows platform, Windows 2012, Windows 2016, Windows 2019 server, they provide a signing SDK and or the signing tool using which you can easily do the signing. But still, as I was talking about that you need to automate the whole process, I normally recommend to all my customers, even if you're using the open source or if you're using any platform which is providing you the code signing capability, you need to incorporate the proper key management and you need to protect those keys and other things. Now, once the code has been signed, the end user who receives the code, how does he trust that particular code, or how the authenticity is being verified? It's kind of a two-step process if we look into that. First thing is that the hash has to be verified, and the second thing is that the certificate using which the signing has happened, that has to be verified. The hash verification is important as we want to ensure that the code has not been tampered. So what happens is that the original code is again passed back to the hashing algorithm, which creates again a hash value. And the bundle which we have received that contains in the certificate the public key information, and that public key information reveals the original hash value which was calculated. So you can now compare basically the old hash value and the new hash value, and if they both match, that kind of proves that the code was not tampered. On the other hand, the certificate using which the signing was performed and the certificate which is attached along with that bundle, you would be verifying that it's coming from the trusted certificate authority, and secondly, that whole validation and the chaining is kind of working. Now, if you think from the practical perspective, like your mom or your dad who are not used to using the computers that much, that how can we help them basically that they can recognize that whether this this can be a malware or this cannot be malware. So simple thing is that like I normally always tell it to my family members that like whenever you install something on the Windows, because that's what they use at house, they need to ensure that the publisher name on the package has to be coming from the well-known publisher. Like if they're, for example, if they are installing a Microsoft Outlook or if they're installing a Microsoft Word, ensure that the publisher is not unknown, it's coming from the Microsoft. Second thing I tell them is that to verify that the certificate which is attached along with that package should be a valid, or should be the publisher name should also be there on that certificate. And third and the last thing is I tell them is that always validate that the whole certificate trust chain is valid, and there's nothing like a red flag there. Now, let's think of a scenario that I bought a Microsoft Office package from the Walmart, and I bought it like 2 years back, and the certificate using which the signing happened was valid for 1 year. Now, does that Microsoft CD or that package becomes invalid? Answer is no. The thing is that you can still use that Microsoft Office installer or DVD even after like 3 or 4 years. The reason for that is that there's a code signing, there's a time stamping certificate which is attached to that. So the time stamping certificate kind of acts as a notary for this whole thing. So it's kind of proves that what time the code was signed and at that time whether the certificate was valid or not. So if I put it in other words, the expired certificate means that the signature validation will fail. And the time stamping was designed to alleviate that problem. That being said, how does the whole time stamping signature is implemented? This I would be reading from the slide. It's like a high 4-level kind of a process, 4-step process. Normally the signature is normally sent to the trusted time stamping authority, and the time stamping authority adds a time stamp to the bundled information and computes the new hash, and the TSA signs the new hash with its private key, creating a new bundle of information. And then the timestamp bundle, the original bundle, and the timestamp are rebundled with the original code, and that's how basically that whole thing works. Now, in most of the organization which you guys work in, all the developers have to sign a code, okay? Now, the thing what I have seen is practically is that when the developers have to sign a code, they have 2 options. One option is that they generate a self-signed certificate using OpenSSL or any other tool which is handy to them, or they go and reach out to your internal PKI team and get a certificate which is being trusted within your organization, or they can, if the organization, if they know about the public CAs and other things, they can get a certificate for which they have to pay maybe few dollars for the code signing certificate from the publicly trusted CA. Now, most of us like to use the free things. We don't want to go and buy something. So most of the developers just try to avoid it, and I don't want to deal with the PKI team, or I don't want to pay the money basically to get a publicly trusted certificate. So they just generate the self-signed certificate using the OpenSSL or any open tools which are out there. And when they do that, they kind of they are putting the company into a risk. The reason for that is that first thing is that whenever they will use a self-signed certificate, you'll always get that unknown publisher tag on the pop-up whenever you will try to install it. Second problem what they lead to is that even if that certificate using which they did the signing get compromised, there's no way you can revoke it. And that can lead to much more bigger problems. And that's where it's always recommended to use the certificate which are being trusted by the certificate authority. And if they do that, they will be following the industry best practices with respect to the cryptography. And on the signature of the pop-up, the publisher name would be valid, and if something happens to the certificate, if it gets compromised, it can be easily be revoked. That being said, these are some of the requirements what normally I suggest to my customer to follow for the code signing. There's no CAP forum requirements which are out there with respect to the code signing, but you can use whatever the requirements have been laid out by the CA CAP forum and can use them as a baseline. I would say like the first is that like a CA CAP forum mentions that you need to use a certificate which should not be more than 27 months. There's another like a article which is under the draft from the NIST, which is coming out I think in few months, which kind of mandates that you should not use a certificate more than 1 year. So I would still recommend to my customer to use a certificate which has a smaller lifetime. I would say 6 months or something like that. Second thing, what I recommend is that always use a little bit higher cryptography, like in the sense like NIST recommends that you should use a RSA 2048-bit key. In spite of using the NIST 2048-bit key of RSA, I would say that if you can get a higher strength key, that will help, or use the elliptical cryptography or other things which are out there. Another requirement which I would like to highlight is that if your organization has a history of takeover attacks, I would recommend that you need to protect that private key using the HSMs or any hardware cryptographic device like TTM and other things, and then use the trusted timestamping authority and the certificate authority. Don't use the self-signed certificates. This kind of leads us to what are some of the best practices which are out there with respect to the code signing. Now, I would say that first thing is that you need to minimize the access to the private key. Like you need to have a proper separation of duties, separation of roles in place, that there should be like a centralized code signing server station where everybody doesn't have an access to the private keys, and you have the control who has exactly have access, and kind of putting dual control in the separation of duties. Second thing I would say is that you need to have a different signing certificate for the production release and a different certificate for the test environment. Don't mingle the keys for the test as well as the production. Third thing, as if you would have seen like in whole of this deck, basically we have to emphasize that the private signing keys are most important and they need to be protected. So I would always recommend to my customer using the FIPS level 2 cryptographic devices like Encipher and Shield Connect or Encipher as a service to use them, so that the keys cannot be compromised that easily. And other thing which needs to be done is that before the code signing actually happens, somebody needs to validate that code, or somebody needs to run it through the malware or the virus scanner. And there should be a proper process or automation should be there so that we can easily track it out who actually approved it, and there's a proper audit trail is there. Those things should have to be in place before the code signing actually happens in the organization. Another thing I would point out is the time stamping code. As we talked about it, that when you're doing the code signing, if you don't use a time stamping, then once the certificate gets expired, then that code won't be trusted. So you need to use the time stamping. I would put a tighter control as well on the code signing certificate. Won't distribute those code signing certificate freely to everyone within the organization. At last, I would like to wrap up with a case study of the Duku, which was a malware attack which happened. So in that particular case, there was a Taiwan-based company called Foxconn, and they are kind of a electronic part manufacturer. And the hackers stole their private signing keys, and once they stole their private signing keys, they tampered the package and they inserted the malware inside it, and people installed that particular firmware package, and that's how the whole kind of a attack happened. Another thing I would like to point out from this particular attack was that the people don't take the code signing keys that seriously, because it's not protecting any PI data or anything like that. Because if you talk to anybody, they protect those keys using which the PI data or any sensitive information is being protected. And I would again emphasize that if you're doing any signing, you need to protect those private keys, and you need to have a proper workflow management in place, and you need to have a proper audit trail that who actually signed and what time it was signed and what was the reason and blah, blah, blah. That's all I have got, and I would take on any questions, and I'll stop here. And Lauren, do you want to take it over?
So real quick, this is Tim. I want to jump in there in a quick second. That again, I want to thank everybody for attending today. Please be on the lookout for an email from us, as there will be a gift in there for you for attending for today's session. Again, we do appreciate it. I'm looking for the questions and answers, and we will wait here for a couple more minutes and see if there's any questions on that. Lauren, do you see anything in the queue?
I see a Kathy. She has some question, and she just typed in the question answer yes. So, Kathy, do you have any question? Can you type your question?
That was before.
Okay. Okay.
So I don't see any other questions in there. Again, everyone, thank you very much. Crazy time we live in. Please stay safe. Be look for the email from us. You should be receiving that within, if not, tomorrow on Monday, you should be receiving an email from us on the follow-up. So again, everyone, thank you. Stay safe and have a great weekend.
Hey, Tim, do you want me to hold on here for a minute, or?
You can jump off. I'm just waiting for everybody to get off.